Okay, so we're back here for part 2, and what we're going to do this time, instead of looking at the confidence interval for two proportions, let's look at the significance test for two proportions. Now we're going to use the same problem here, but I'll reread what our situation is. A recent random sample of 200 US females revealed 110 use Twitter regularly. A separate random sample of 150 males revealed that 60 use Twitter regularly. Do the data provide convincing evidence that US females use Twitter more regularly than US males? Use a 5% significance level. So what we calculated the last time, just for the proportions, we know that the females, the sample proportion, which we'll call p hat 1, is 110 divided by 200, which is 0.55. And for the males, which we'll call p hat 2 for their sample proportion, that was 60 over 150, which is 0.4. Now when we do a confidence interval, we're doing panic, but when we do a significance test, our acronym is phantoms. Is the word phantoms. So P and H go together, A and N, T and O, and then M and S. Now the P and the H, that means we define the parameter and we write down our hypotheses, the null hypothesis and the alternative. So the null hypothesis, in this case, is that there is no difference between the true proportion of females and males that use Twitter regularly. So in other words, we're saying that these are equal, or when you subtract them, you get 0. The alternative, however, it says, do the data provide convincing evidence that US females use Twitter more regularly? So that's the key there. What we're going to try to determine, is this true difference of proportions actually greater than 0? In other words, is P1, the female proportion, greater than the male proportion P2? And on the side here, I'm going to write down the P1 minus P2 is the true difference. So this is where we're going to define the parameters, is the true difference in proportions of US females minus US males that use Twitter regularly. Okay, so we've got, this is the P and the H on the side. All right, so then we go to the A and the N. Well, A is the assumptions. Those are all of the 3 conditions we always have to check for. And then N is where we name the test that we're going to do. Well, the assumptions, now we've already done these. We did these for the confidence interval. So random, yes. Both of the samples were random. The 10% condition, the 10% rule, yes. We can assume that 200 females, the 200 females is less than or equal to 10% of the overall population of US females. We can do the same thing for the males. And then because we're doing proportions, we're looking at the large counts condition, that the number of successes and failures has to be greater than or equal to 10 for both male and female. For the females, we have 110 that use Twitter. That means 90 do not. Both of those are greater than or equal to 10. And then for the males, we have 60 that use Twitter and 90 do not. Those are greater than or equal to 10. Okay, so we showed those back on in the other video. So that is the assumptions. Now, the name of the test, we always have to write this down. This is a 2-sample z-test for proportions. Or we could say P1 minus P2. A 2-sample z-test is what we are performing here. Now, if we're talking about means, this is probably going to be a t-test. Well, that'll be the next section. All right, so now what we have to do is we have to obtain the test statistic. We have to obtain the z-score. And then we have to use that to calculate the p-value. We obtain the p-value. The general formula to find the standardized test statistic is we take the statistic minus the parameter divided by the standard deviation of the statistic. Standard deviation of statistic. Okay, now I'm going to show you this and how you can calculate this algebraically. However, you are not going to want to do this on the AP exam. You are going to use the calculator. But just to show you what it looks like, and you'll see right away why we want to use the calculator. So the equation here to calculate our z-score, now the statistic is the difference of the sample proportion. So that's p hat 1 minus p hat 2 minus the parameter is the true proportion of females minus the true proportion of males divided by, and this is where it gets a little interesting, the standard deviation of the difference of the proportions. I'm going to introduce p hat c times 1 minus p hat c divided by n sub 1 plus p hat c times 1 minus p hat c divided by n sub 2, that's sample size. Now you're asking, whoa, where did that come from? Because we do have a formula for standard deviation of the differences of the sample proportions. And that was the square root, where we took the sample proportion for the women times 1 minus that divided by the sample size for the women plus the sample size for the males times 1 minus their sample size divided by the proportion, of males times 1 minus their proportion divided by the sample size of the males. Now you'll notice that this is not the same as what we have here in this formula. So what's changing? Well, we've got a problem here. Remember that in the null hypothesis, we are assuming that the true proportions are the same, that the proportion of females and the proportion of males are equal. But when we use this formula, they're not. This is 0.55 and this is 0.4. So if we're assuming they're equal, why are we going to use values that are not equal? What happens here is that we need to come up with a good estimate for these values. And the way we'll do that is we're going to find the sample proportion combined. So that C stands for the combined sample proportion. So what we're going to do is we're going to take the number of females that use Twitter regularly. We're going to combine that with the number of males that use it. So 110 plus 60 over, so divided by the total number of females in the sample and the total number of males. So we get 170 divided by 350, which works out to a decimal 0.4857. And you'll notice that that value is between the females and the males. So what we're doing here is we are estimating this sample proportion because, again, in the test, we're assuming that these are the same. So we're going to use this. All right, so now we substitute our values, and again, this is a mess. So z equals p hat 1 minus p hat 2, that was for females 0.55 minus proportion of males 0.4. Now what happens in this case, p1 minus p2, the true proportions, remember we're saying that those are equal to each other. So their difference is 0 over, and then we have the big square root. We're going to use the same combined proportion in both of these fractions here. So 0.4857 times 1 minus that divided by 200, that was the sample proportion, the sample size for the females, and then 0.4857 times 1 minus that, divided by 150, the sample size for the males. And now we can calculate our Z statistic here. There are a lot of ways that I can make mistakes typing this and writing this. So this is why I'm saying, I'm showing it to you, and I'm going to go through the calculation. Whoops, see, I already made a mistake. Okay. Square root. So I need a, geez, I'm struggling. Okay, the square root and the first fraction, 0.4857 times 1 minus 0.4857 divided by 200, that's for the females, plus another fraction, 0.4857 times 1 minus that, 4857, divided by 150. Okay, so I think that is all correct now. So 2.779. 2.779. That is our test statistic that we get. So that's our Z value there. Now what we're doing, remember that when we test, when we do the large counts, that's telling us that our distribution is approximately normal. And so now we take the Z-score and we're going to look at a normal approximation, a normal distribution. Now you have to make a decision here. 2.779, this is the number of standard deviations away from the mean. Well, that could be to the right, and it could also be to the left. In this case, well, it's a positive, so I'm going to be here. So here's 2.779. We want to use our null hypothesis, or our alternative hypothesis, actually. Remember where we're trying to look at. We want to show whether there's a significant change in these proportions where the proportion of female users is greater than the proportion of male users of Twitter for that. So because this is greater than, we're looking at, we think that this proportion, the females, is higher. So we're looking at this part of the curve, the right tail, where we have the greater values. If this had been a less than symbol, then we would be looking at this portion of the tail on the left side. If we thought that the true difference of proportions was not equal to 0, if we just want to say the proportion of females is different from the proportion of males, then we would look at both sides of this. So I'm going to do a normal CDF. So 2.779 is the lower bound. I'll make 1,000 the upper bound. 0 and 1 are my mean and my standard deviation. Okay, so calculator, normal CDF, and 0.0027. That is our p-value. So we get p-value equals 0.0027. The p-value is the probability, assuming that the null hypothesis is true. So assuming that there's really no difference between the proportion of male and female and male users, the probability of obtaining this test statistic or more, of getting these results or more extreme, is very, very low. It's 0.0027, which is basically 0. It's almost 0. So this is very highly unlikely. So the last thing we want to do here is we're going to make our decision, that's M, and we're going to state our conclusion. Now the decision is we're either going to reject H0 or we're going to fail to reject. In this case, since the p-value of 0.0027 is less than the significance level alpha equals 0.05, we reject the null hypothesis, H naught. So our conclusion is there is convincing evidence that, now there's a couple ways to phrase this. I'm going to say the true proportion of US females that use Twitter regularly is greater than the true proportion of US males. You could also say, if you wanted to restate the alternative exactly how we wrote it, you could say the true difference of proportions of females minus males is greater than 0 for that. But in this context, what we're trying to say is that that a higher proportion of females uses Twitter on a regular basis than the proportion of US males. All right, so here we go. We're done. But the amount of time it took to do this, we don't want to spend that amount of time, so we could have done this in a much easier way. Stat, test. Now what we need is a two-proportion z-test. The name of the test is a two-sample z-test, but on the TI-84 we do two-proportion z-test. And for the females, that's X1, 110 out of 200 in our sample. Use Twitter. The males was 60 out of 150. Now in this case, we're saying that P1 is greater than P2 for the alternative, and we calculate it. And look at that. Here's the z-score. The test statistic is 2.779. The p-value is 0.0027. If you use the calculator, or when you use the calculator, make sure you write down your z-statistic. Make sure you write down your p-value, or else you will lose points on the test. And that is the end of part 2.